Hello students, I hope you all are doing good. Today we are going to start a new chapter, surface areas and volumes. These are all about the solid shapes we have already studied. We have studied about a cube, a sphere, a cone, a cylinder and a cuboid. Now let us see where we find these solid shapes in our daily life. A gas cylinder, a water bottle, your Coca-Cola can, these are all cylindrical shapes. Then we have a globe and a ball in a shape of a sphere. Water tanker, again a cylindrical shape, and your birthday cap. You can also see many other shapes around you. So, let us revise some formulas for surface areas and volumes of these shapes. The first one is a cube. Surface area of a cube is 6a square. Now, what is A? A is any edge of the cube. Also, we know that all the edges are same in the cube. So, volume of the cube is A cube, that is 3 times A. A into A into A. Let us move forward to a cuboid. Surface area of a cuboid is 2LD plus 2LH plus 2HD. What are these? L is the length, this is the length, D is the depth, this is the depth, and H is the height. Similarly, volume of a cuboid is length into depth into height, that is L, D, H, right? Length into depth into height. So, let us move forward to other shapes. Next shape is a cylinder. In a cylinder, surface area of a cylinder is 2 pi r into h, that is 2 pi r h. What is r? R is the radius. It is the radius of the cylinder. And what is h? H is the height of the cylinder. You can see clearly in the figure, area of this base of a cylinder is a circle. So, area of this base is A is equal to pi r square. Similarly, area of the topmost is A is equal to pi r square, whereas area of this curved surface is 2 pi r into h, 2 pi r into h. Also, TSA. What is TSA? TSA is total surface area. So, total surface area of the cylinder is 2 pi r square plus 2 pi r h, as I had mentioned here. 2 pi r h plus pi r square plus pi r square, right? Now, volume of a cylinder is pi r square h, pi into r square into h, and the value of pi can be 22 by 7 or 3.14. Let us move forward to other shapes. Now, the next shape is a cylinder. Here, CSA of cylinder. What is CSA? CSA means curved surface area. So, curved surface area of a cylinder is 2 pi r into h, that is 2 pi r h. Now, what is r? R is the radius of the cylinder. R is the radius of the cylinder, right? And what is h? H is the height of the cylinder. This is h. So, the CSA or the curved surface area is circumference into the height, that is 2 pi r into h, that is 2 pi r h. Now, TSA of cylinder. What is TSA? TSA is total surface area. So, total surface area is curved surface area of the cylinder plus the area of the base plus the area of the top. Now, area of the base is pi r square. Why pi r square? Because it is a circle and area of a circle is pi r square. Similarly, top of the cylinder is also a circle, so pi r square. Let us move over to the cone. The curved or the lateral surface area of the cone is pi r l. What is L? L is the slant height and R is the radius of the cone, radius of the base of the cone. So, curved surface area is pi into R into L. Total surface area of the cone is the surface area of the curved surface plus the area of the base. So, we have pi r l plus pi r square. Why pi r square? Because this base is a circle. This is a circle. So, pi r square, that is the area of the circle. Also, we know that volume of a cone is 1 by 3 pi r square h. 1 by 3 pi r square h. Now, just have a look. Volume of a cylinder is pi r square h and volume of a cone is 1 by 3 pi r square h. What do you understand by this? That volume of a cone is 1/3 of the volume of a cylinder. So, let us move forward to our next shape, that is a sphere. Surface area of a sphere is 4 pi r square. What is r again? Again, r is a radius of the sphere. Similarly, volume of the sphere is 4 by 3 pi r cube, radius cube. Now, let us see the hemisphere. Curved surface area of the hemisphere. Curved surface area, this one. Curved surface area is 2 pi r square and total surface area is 3 pi r square. Why 3 pi r square? Because curved surface area plus the area of the top. This is again a circle and area of the circle is pi r square. So, 2 pi r square plus pi r square, we have 3 pi r square. Also, volume of the hemisphere is 2 by 3 pi r cube. You can note this. Surface area of the sphere was 4 pi r square and hemisphere is half of the sphere. So, curved surface area of the hemisphere is 2 pi r square. Similarly, volume is 4 by 3 pi r cube and volume of the hemisphere is half of that, that is 2 by 3 pi r cube. Now, we have studied about all the shapes. We have now area of combination of shapes. These are the combination of shapes you see all around you. The ice cream cone, this is a combination of a cone and a hemisphere. Similarly, a capsule. See this figure carefully. You have two hemispheres here, one hemisphere and second hemisphere, and in between that we have a cylinder. Similarly, this is a toy rocket. We have a cylinder and a cone here, right. So, these are the combination of solids. Now, let us see how we can apply these formulas in the combination of solids. Rashid got a playing top Lattu as his birthday present, which surprisingly had no color on it. He wanted to color it with crayons. The top is shaped like a cone surmounted by a hemisphere. The entire top is 5 centimeter in height and diameter of the top is 3.5 centimeter. Find the area he has to color. Here we need to take pi as 22 by 7. This is a top, this is a cone and surmounted by a hemisphere. This top is a combination of a hemisphere and a cone. So, what is the total surface area of the cone? The total surface area of the toy is CSA of the hemisphere, right, plus CSA of the cone, that is curved surface area of the hemisphere plus curved surface area of the cone. Now, let us apply the formulas. What is curved surface area of the hemisphere? It is given by 2 pi r square. So, applying the formula, we have 2 into 22 by 7, that is the value of pi, into 3.5 by 2. Why 3.5 by 2? Because diameter is 3.5. So, radius will be 3.5 divided by 2, right, into again 3.5 divided by 2 centimeter square. Also, the height of the cone, this height will be height of the top minus height, that is radius of the hemisphere. This is the total height, that is 5 centimeter, and radius is 3.5 minus 3.5 upon 2. So, what we have to do is 5 centimeter minus 3.5 upon 2 and we get 3.25 centimeter as the height of the cone. So, the slant height of the cone given by L is under root of r square plus h square. We know the values of r and h. Substituting the value of r and h, what we have is 3.7 centimeter as the slant height L. Therefore, the curved surface area of the cone pi r L, substituting again the value of pi r L, we have this. Now, this gives the surface area of the top. What is the surface area of the top? It is the curved surface area of the hemisphere plus the curved surface area of the cone. So, we add these two and we get 39.6 centimeter square. This is the total surface area of the top. So, let us move forward to our next example. A vessel is in the form of a hollow hemisphere mounted by a hollow cylinder. The diameter of the hemisphere is 14 centimeter and the total height of the vessel is 13 centimeter. Find the inner surface area of the vessel. The radius of the hemisphere is r, that is 14 by 2 is equal to 7 centimeter. Why 14 by 2? Because diameter is given as 14 centimeter. So, radius will be 7 centimeter. Also, height of the cylinder. What is height of the cylinder? It is the total height minus the height or the radius of the hemisphere. So, we have 13 minus 7, that is 6 centimeter. Now, the total inner surface area of the vessel will be inner surface area of the hemisphere, the inner surface area of the hemisphere plus the inner surface area of the cylinder, right. So, that is the formula is 2 pi r square plus 2 pi r h. R is the radius and h is the height of the cylinder, right. So, substituting all these values, we can put the value of pi later on to avoid long calculations, that is 98 pi plus 84 pi. Adding these two, we have 182 pi. Now, we can substitute the value of pi and calculate as 572 centimeter square. I hope you have understood this example. Now, let us move forward. Example number 3. Mayank made a bird bath for his garden in the shape of a cylinder with a hemispherical depression at one end. The height of the cylinder is 1.45 meter and its radius is 30 centimeter. Find the total surface area of the bird bath. Here again pi is equal to 22 by 7. Let h be the height of the cylinder. What is h? The height of the cylinder, and according to the question, height of the cylinder is 1.45 meters and the common radius be r. This is the common radius of the hemisphere as well as the cylinder. This is given in the question as 30 centimeter. Now, the total surface area of the bird bath is surface area of the cylinder plus surface area of the hemisphere. This plus this. So, putting on the formula, we have 2 pi r h plus 2 pi r square. Substituting again the value of pi, r and h, we have 33,000 centimeters square. Let us convert 33,000 into meters. We have 3.3 meters square. I hope this question is clear now. Let us move forward. Example 4. A medicine capsule is in the shape of a cylinder with two hemispheres stuck to each of its ends. The length of the entire capsule is 14 millimeter mm and the diameter of the capsule is 5 millimeter mm. Find its surface area. Now, in this capsule, what is given? The length of the entire capsule is given as 14 millimeter and the diameter of the capsule is given as 5 millimeter. So, the total surface area of the capsule will be surface area of the cylindrical part. This is the cylindrical part, right? And twice of curved surface area of the hemisphere. This is one hemisphere and this is the second hemisphere. So, substituting the formulas, we have 2 pi r h plus twice of 2 pi r square. Taking 2 pi r common, we have h plus 2 r. Now substituting the value of R as 2.5, H as 9, again R as 2.5 and calculating the same, we have 220 millimeters square. So, the total surface area of this capsule is 220 millimeters square. I hope you have understood this example. Now, let us move forward. Example number 5, a wooden article was made by scooping out a hemisphere from each end of a solid cylinder. If the height of the cylinder is 10 centimeter and its base is of the radius 3.5 centimeter, find the total surface area of the article. This is the article. Now, height of the cylinder is 10 centimeter. This is 10 centimeter and base radius is given as 3.5 centimeter. This is the base radius, this is given as 3.5 centimeter. Both the radius are 3.5 centimeter. Curved surface area of the cylinder can be given as 2 pi r h. Substituting the values, we have 220 centimeter square. This is the curved surface area of the cylinder. Now, inner surface area of the hemispherical cavity. This is the hemispherical cavity, right? So, what is the inner surface area? This is given by 2 pi r square. Now, again substituting the value of pi and r square, we have the value as 77 centimeter square. Inner surface area of both the hemispherical cavity. Why both? Because we have one hemispherical cavity here and the other as here. So, we have 77 plus 77, that is 154 centimeter square. Now, the total surface area of the solid will be curved surface area of the solid plus inner surface area of both the hemispherical cavity. So, we have 220 centimeter square plus 154 centimeter square, that comes out to be 374 centimeter square. I hope this example is clear now. Till now, we have studied about the surface areas of combination of solids. I hope all the concepts are clear. Thank you.